Hey everyone, welcome back. I'm so excited you're here because today we're going to make our Guess a Number game actually interactive. In our last video, we learned about the start and update methods in Unity. We discovered that start runs only once at the beginning, while update runs every single frame. Think of update like your heartbeat. It keeps going continuously. Today, we're going to use that update method to listen for keyboard presses. Instead of hard coding our guesses like we did before, you'll actually be able to type numbers on your keyboard and play the game for real. We'll be using Unity's new input system. Now, don't worry if that sounds scary. I promise we'll take it step by step, and by the end of this video, you'll have a fully playable guessing game. Think of this like learning to cook. We're starting with a simple recipe before we become master chefs. Later, when we build our 3D games, we'll learn the more advanced techniques. So grab a cup of coffee and let's dive in. Before we start coding, let me explain something really cool. Unity actually gives us two different ways to handle input. That's like keyboard presses, mouse clicks, or gamepad buttons. The first way is called the device API. This uses simple commands like Keyboard.current.enter key. It's like asking, hey keyboard, was the enter key pressed right now? It's direct, easy to understand, and perfect for learning. And of course, we can stick with this if it works or we don't have much logic in our game. The second way is called input actions. This is more like setting up a smart system that can automatically handle keyboards, gamepads, touchscreens, and even let players customize their controls. It's super powerful, but it's like trying to learn calculus before you know basic math. Since you're just starting your Unity journey, we're going with the first approach today. It's like learning to ride a bicycle with training wheels first. Once you're comfortable with this, the advanced stuff will make so much more sense. And here's the best part. Everything we learn today will still work when we upgrade to the advanced method later. We're building a solid foundation, not throwing away work. Now, if you're using a recent version of Unity, like 2022 or newer, the new input system is already installed for you. That's great news. Unity made our lives easier. But let's double check together. Go to Window, then Package Manager. Make sure you're on Unity Registry in the dropdown. Now search for Input System. If you see it with a green check mark or it says up to date, perfect, you're ready to go. If you see an install button, click it. Unity will ask if you want to enable the new input system and restart. Click yes and let Unity restart. When I was recording this video, I noticed there was actually an update available for the input system package. I quickly clicked update to get the latest version. If you see an update available, go ahead and grab it too. It's always good to stay current. If you're using an older version of Unity and don't see the input system at all, you might need to upgrade Unity or manually add it. But for most of you watching this, it should already be there. Now, before we start coding, I need to explain something super important. We're going to change our player guess from an integer to a string. Let me tell you why this is actually brilliant. Think about how you type a number like 573. You don't magically think 5 of 73 and it appears. You press 5, then 7, then 3. Each key press adds one digit to build up your complete number. If we used an integer, we'd have a big problem. Integers can only store complete numbers like 5, 57, or 5 and 73, but they can't help us build up a number one digit at a time. Strings, on the other hand, are perfect for this. A string can hold 5, then become 57, then become 573. Think of a string like a word that can grow letter by letter, or in our case, digit by digit. Here's a fun analogy. Imagine you're building a sandcastle. An integer is like trying to place the entire castle at once. Impossible. A string is like adding one handful of sand at a time until you have your complete castle. So when the player presses 5, we add 5 to our empty string. When they press 7, our string becomes 57. When they press 3, it becomes 573. Finally, when they press enter, we convert that string 573 into the integer 573 for our game logic. It's like collecting puzzle pieces, individual key presses, and then assembling them into the complete picture, the final number. Let's look at our current script and make the necessary changes. First, we need to tell Unity we want to use the new input system. At the top of your script, add this line, using Unity Engine.input system. This is like telling Unity, hey, I want to use your new keyboard detection superpowers. Another important step is to move all our variables to the class level so they're accessible across all functions and methods. Now let's change our player guess variable. Find this line, int player guess equals 18, and change it to string player guess equals empty string. If we don't write anything inside double quotes, then it becomes empty. We're starting with an empty string, like having a blank piece of paper ready for the player to write their number on, one digit at a time. We'll keep using the same variables we had from our previous video, just changing player guess from int to string so we can build numbers digit by digit. Also, let's add a secret number that the computer will generate randomly, int secret number, and initialize it with default value of 500 for now. Now we have a small issue here. Since we changed our player guess variable to a string, we get an error. A string cannot be compared to a number like 20 because 20 is an integer, while our player guess is text. Yes, we could write player guess equals 20 inside double quotes so it compares two strings, but that's not what we actually want. In our upcoming videos, we'll learn how to convert a string into an integer and how to properly use that in comparisons. For now, we don't need these if statements or the log statement we used earlier just for learning purposes. So let's clean up our start method and also remove those unnecessary logs from the update method. Now comes the exciting part, detecting when the player presses keys. This all happens in our update method because remember, update runs every frame, so it can catch key presses the moment they happen. Let's start with detecting the number 0. Here's the magic code. So when the 0 key gets pressed, we'll drop that into the player's guess, and we'll print it out in the console so we can see what they've got so far. Let me break this down like we're learning a new language. Keyboard.current means the keyboard that's currently connected to this computer. Digit 0 key means the 0 key on the top row of the keyboard. wasPressedThisFrame is asking, was this key pressed during this exact frame? Remember, update runs many times per second, so this checks if the key was pressed right now. If the answer is yes, we do two things. We add 0 to our player guess string using the plus equals operator. This is like gluing the new digit onto the end of what we already have, and is equivalent or shortcut of player guess equals player guess plus 0. We show the current guess in the console so the player can see what they've typed. But wait, most keyboards have two 0 keys, one on the top row and one on the number pad. Let's handle both. The double vertical bars mean OR in programming. So this says if either the top 0 or the numpad 0 was pressed, add a 0 to our guess. Now let's do the same for adding the number 1. I know what you're thinking. This looks very repetitive, and you're absolutely right. In our next video about functions, we'll learn how to make this code much shorter and cleaner. For now, we're focusing on understanding how input detection works. Let's continue with all the numbers. The pattern is exactly the same for each digit. Only differences is the digit which we change in every steps. And we continue this pattern for digits 3, 4, 5, 6, 7, 8, and 9. Yes, it's a lot of typing, but you're learning the fundamentals. If you're an absolute beginner, then don't copy and paste for now. Type each code yourself so it will be easy to remember later. Now for the big moment, the Enter key. This is where the magic happens. Here's what happens step by step. We check if Enter was pressed and the player actually typed something. We convert the string 573 into the integer 573 using int.parse. We show them what they entered to confirm the input system is working. We clear their input so they can type something new. The int.parse is like a translator that converts text numbers into real numbers that the computer can work with. For now, we're just showing the number back to them to prove our input system works perfectly. Let's test our masterpiece. Press the play button in Unity. Now try typing some numbers on your keyboard. You should see them appear in the console window as you type. Try typing 1, 2, 3. You'll see 1, then 12, then 123 building up. When you're ready, Press Enter to see your complete number displayed back to you. This proves our input system is working perfectly. One problem you might face is that when you type a number or provide any input, it doesn't work. This happens because our game only responds when the game view in Unity is focused. If you accidentally click somewhere else, like the console, you lose focus from the game view, and input won't work. To fix this, just click back on the game view to give it focus again. You've successfully captured keyboard input and built multi-digit numbers. Amazing work. Congratulations. You've just learned some incredibly important concepts. First, you understand why we use strings to build multi-digit numbers, because we need to collect digits one by one, like building blocks. Second, you've mastered the basics of Unity's new input system using Keyboard.current. This is a skill you'll use in every game you make. Third, you've seen how update method continuously checks for input. This pattern is fundamental to game development. In our next video, we're going to learn about functions. You noticed how repetitive our key checking code was, right? Functions will help us write the same functionality with just a few lines of code instead of dozens. It's like learning shortcuts that make you a more efficient programmer. After we clean up our code with functions, then we'll add the actual guessing game logic with random numbers and win-lose conditions. We're building this step by step so you understand each piece perfectly. This guess a number game is all about getting the hang of Unity and C# fundamentals. We're going in depth here because in future videos we'll move faster. So take your time, practice, and really lock it in. I hope you enjoyed this journey into Unity's input system. You've transformed a static guessing game into an interactive experience. That's the power of programming, turning ideas into reality. If this video helped you understand input systems better, please give it a thumbs up. If you want to continue this Unity learning adventure with me, hit that subscribe button and ring the notification bell. I read every comment, so let me know, what kind of game do you want to build next? A platformer? A racing game? A puzzle game? Your feedback helps me create content that truly helps you learn. Keep practicing, keep experimenting, and remember, every expert was once a beginner. You're doing great. I'll see you in the next video where we'll make our code much cleaner with functions. Until then, happy coding.